All right, let's solve this trigonometric equation. So the first thing to do is to isolate the cosine. We're really trying to find out what x is, but first I've got to isolate this, so divide by 2. So I've got cosine of 4x equals 1/2. Now take the square root of both sides, so the cosine of 4x now equals plus or minus the square root of 1/2, which, by the way, is the same as plus or minus root 2 over 2, if you simplify that. So you're thinking to yourself, oh, that's easy. Those are on my unit circle. Those are all the cosine is your first one. It's all of these, all of the 45-degree angle ones. So it's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Got it? But the trick is here. The trick is the fact that this is 4x. It's saying cosine of 4x equals that. So let's substitute u. We're going to call u 4x. So I'm going to say the cosine of u equals plus or minus root 2 over 2. Right? Which means u equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, etc. Why etc.? Because you can keep going and going around in the circle, right? So there's a couple ways you can do this, because remember we excuse me, we have to solve for u, not for, sorry, we have to solve for x, not for u. So what you do now is you write 4x equals pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and you keep going in both directions, negative and positive. You can keep going in the negative direction, negative pi over 4, negative 3 pi over 4, negative 5 pi over 4, etc. But how do I know what the answers are? Well, again, I'm trying to solve for x, and I'm trying to solve it over the one full revolution around the unit circle. So my answer is x equals pi over 16, 3 pi over 16, 5 pi over 16, 7 pi over 16. You can see the pattern, can't you? It'll keep going every odd. That's one way you could do it. Another way you could do it is recognize that the period for this is what? 2 pi over 4. Remember that trick? The period is 2 pi over 4, which means the period is pi over 2. So you could, to each one of these things, it's add pi over 2 to each one of them, because that'll give you another answer, because that's what a period means. Okay? So you could do it like that. And what, of course, is pi over 2 the same as? 8 pi over 16. Right, so I'm adding 8 pi over 16. So this also equals, add 8 to 1, and you get what? 9 pi over 16. Add 8 to 3, and you get what? 11 pi over 16. Add 8 to 5, you get 13 pi over 16. Add 8 to 7, you get 15 pi over 16. And we're not even close to being done yet. Can you see why? Because we're not even at pi yet, and we need to get to 2 pi. So how do I do that? Well, add another 8 pi over 16, or pi over 2. Add another one to all of these here. Add 8 pi over 16 to each one of these. And you'll get more numbers. And essentially, you can see what's happening. It's just you're just adding 2 each time. It's all the odd numbers over 16. So this example is actually relatively easy, because you can kind of see a pattern. You don't even have to use that trick I showed you, but it's good to know that little trick I was talking about. So 17 pi over 16, 19 pi over 16, 21 pi over 16, 23 pi over 16. Should I keep going? Well, is 25 pi over 16 still smaller than 2 pi? Yeah, 25 is less than half of 16, so yes. So 27 pi over 16, 29 pi over 16, 31 pi over 16, and now I can be done. Because if I go to 33 pi over 16, that's bigger than 2 pi or 32 pi over 16. So there are my answers, and I have 16 answers. Why are there so many answers? Well, because this is squared, first of all, and because the period is so small because of that 4 there. That says basically go around the unit circle 4 times to find all the answers. So those are all of your answers.